Welcome back to Diary of the Cosmos. Tonight we drift toward a world that may already be gone from our sky, yet still lives on in the light crossing the dark. Far from Earth, beyond the quiet geometry of our local stars, there may be places where our planet has never become what we know it to be. Not because time itself has changed, but because light is slow. Slow enough that distance becomes memory, and memory becomes a sky. If an ancient civilization once built a telescope large enough to study distant worlds across interstellar or even intergalactic scales, what they would see would not be our present. They would see whatever version of Earth the arriving photons still carry. A younger planet, a different century, perhaps a night sky with no cities, perhaps oceans untouched by ships, perhaps a world still waiting for the first mind to wonder what the stars are. The darkness does not keep secrets. It preserves delays. Every ray of light leaving Earth slips outward into the universe as a thin, expanding shell. A silent sphere of information. 1 year away, it carries a year-old Earth. 1,000 light years away, it carries a medieval Earth. Millions of light years away, it carries an Earth so ancient that even our oldest civilizations have not yet begun. The universe is not simply space. It is layered time. And somewhere inside those layers, every version of this planet still exists as visible history. Seen from the right distance, Rome still stands. The pyramids are still unfinished. The first forests still breathe. The first mammals still wait in the shadows of larger lives. The idea feels almost supernatural. Yet it is only physics. Nothing in this vision requires fantasy. Only distance, only patience, only the finite speed at which light moves through the dark. Modern astronomy already lives inside this principle. When we look at distant galaxies, we do not see what they are now. We see what they were when their light began the journey. The deeper our telescopes reach, the further backward the universe opens. Some galaxies appear to us as they existed billions of years ago, when stars were younger and structure itself was still forming. In that sense, every telescope is already a machine for recovering lost ages. Not by traveling into the past, but by waiting for the past to arrive. An ancient alien telescope would obey the same truth. No matter how advanced, no matter how vast its mirror, no matter how patient the civilization behind it. Its power would not come from magic, only from collecting older and fainter light. More photons, sharper separation, a clearer reconstruction of what once was. And if that civilization had endured for millions, perhaps billions of years, then the patience required for such observations would not even feel extraordinary. A century might feel brief. A million years might feel like routine archival work. For them, watching distant worlds could resemble astronomy, or archaeology, or memory, perhaps all three at once. Imagine their observatory, not as a machine of chrome and blinking panels, but as something older than empires, a structure built to outlast suns, a patient eye suspended in darkness, gathering the dim glow of civilizations that may no longer exist. Its gaze falls upon a small star, a yellow one, ordinary by galactic standards. Around it, a faint rocky planet, blue, clouded, alive. But what reaches that instrument depends entirely on where they are. At 100 light years, they would see our recent century. The first radio leakage beginning to whisper into space. Cities glowing softly across the night hemisphere. Aircraft tracing thin silver paths through the atmosphere. A world just beginning to alter its own planetary spectrum. At 1,000 light years, the signals change. The cities disappear. No electric grid, No satellites, no aircraft. Only firelight. Storms, seasons, empires rising and dissolving in silence too faint to resolve directly. And further still, the human story itself falls away. From tens of millions of light years, the Earth they observe may still belong to the age of dinosaurs. A green and violent planet beneath a brighter, harsher sky. No language, no telescopes, no memory of itself. Only forests, oceans, predators, ash, and time. The beauty of this idea is not that aliens are watching us. It is that the universe naturally stores every stage of becoming, every civilization we once knew, every memory ever carried by starlight. Still moving outward, still waiting to be seen. The darkness does not arrive all at once. It opens in layers. This is what makes distance feel so different in cosmology. Farther does not simply mean more remote. It means older. To cross enough distance is to leave the present behind. A sufficiently ancient observer would not need a time machine to witness Earth before humanity. They would only need to stand in the right place and know how to look. There is something strangely humbling in that. We tend to think of the present as universal, as if now is a shared condition. But the cosmos offers no single now, only local presence, local skies, local arrivals of light. In one distant region, the photons leaving Earth tonight have not yet reached the edge of a nearby molecular cloud. Elsewhere, the light of our earliest civilizations is only now brushing the mirrors of some possible instrument. And in a still more distant darkness, even the Cambrian oceans may remain visible. The Earth exists in fragments across the universe, not as copies, but as delayed truths, a distributed archive of time. This is why the thought of an ancient alien telescope feels so haunting. Not because it introduces something unnatural, but because it reveals how ordinary reality already is. The cosmos does not forget. It merely spreads events apart. A childhood star, a first city, a first machine, a first voice carried by radio into the void. All of it continues. Thinner, fainter, wider, yet still real in the language of light. For a civilization old enough to think in geological patience, our history would not be buried beneath soil. It would be suspended in the sky. The telescope would not scan a planet. It would read a century, or an epoch, or the first trembling hints of life rising from ancient oceans. And perhaps the most beautiful part is this: they might not know they are looking at a future intelligence. To them, Earth may appear unfinished, a blue silence, a biosphere still experimenting, a world on the edge of possibilities not yet written. The stars above that telescope would remain still, but the light inside it would move with ghosts. A young Earth, a changing Earth, a world that, from their distance, has not yet learned to ask whether it is alone. And as their mirrors continue gathering those ancient photons, the question slowly changes. Not what Earth is, but what distance allows any mind to remember. Because if space is large enough, then every past remains visible somewhere. Not forever, but long enough to matter. Long enough for another intelligence to raise an eye toward the dark and discover that time itself has texture. A texture made of light. And somewhere farther out, beyond the quiet boundary of our familiar age, there may already be an observer studying a version of Earth that still belongs to silence. A world before voices, a world before cities, a world before us. And beyond that older Earth, still farther into the black, waits the deeper question, not what they see, but how clearly the universe allows one civilization to read the life of another. The farther they move from us, the younger we become. Not in truth, only in light. What leaves Earth does not vanish into abstraction. It travels, a continuous expanding shell carrying a specific version of this planet into the dark. Every second of our history becomes a larger sphere. Every century becomes a wider boundary. Every age becomes a radius written in photons. For an ancient civilization observing from afar, distance would not merely separate them from us. It would sort us by era, by atmosphere, by the kind of light our world was capable of producing when those photons began their journey. A telescope pointed toward Earth would not discover a single answer. It would discover layers. At one distance, they might see a world of electricity. At another, a world of candlelight. Farther still, a world of untouched forest canopies and migrating ice. And beyond even that, a planet whose continents are familiar, yet whose skies belong to creatures we never knew. The darkness between stars is not empty. It is chronological. This is the quiet truth hidden inside cosmology. We often imagine the universe as a map of places, but it is equally a map of moments. Every light year is a year of delay. Every million light years is a million years of preserved change. What an ancient alien telescope really studies is not simply remote geography. It studies vast temporal geometry, the shape of history as it spreads through space. Imagine Earth surrounded by transparent spheres. The first sphere contains the light of this year, the next, last year. Farther out, the centuries widen into larger and colder shells. Industrial smoke, pre-industrial darkness, bronze tools, ice sheets, dense jungles, meteor fire. At roughly 65 million light years, one of those shells would still contain the closing chapter of the dinosaurs. The impact flash itself, in principle, continues outward as a thin, luminous memory. Somewhere, if distance and line of sight align, that ending still has not finished. The asteroid is still falling. The sky is still brightening. The forests have not yet gone dark. This is not poetic exaggeration. It is the direct consequence of finite light speed. The same reason we see distant galaxies in youth also means distant observers see us in ours. The universe distributes every event across different observers. No single cosmic audience shares the same now. There is only arrival. And the arrival depends on where one waits. This changes the meaning of observation. A sufficiently patient civilization would not think of Earth as one world. They might catalog it as many. Earth 0. A blue world with global electrical signatures. Earth 1000. A quieter biosphere with no artificial orbital structures. Earth 1000 Dozer. An early mammalian world still healing from extinction cycles. Earth 65 Dozer. A reptilian planet beneath dust-rich sunlight. Each is real, not as alternate timelines, but as physically separated layers of delayed truth. The darkness does not preserve the whole story in one place. It stretches the story thin across distance. This is why cosmology often feels closer to archaeology than travel. To look farther is not merely to look outward. It is to excavate older surfaces of reality. Ancient alien astronomers, if they existed, may have learned this lesson long before building instruments powerful enough to test it. Perhaps their first realization was the same as ours. The stars are memory. Their second realization may have gone further. Planets are memory too. A living world is not confined to its own present. It leaks its past into the universe continuously. Every lightning storm, every volcanic eruption, every shift in atmospheric chemistry, every moment of biological transformation. All of it moves outward as readable structure. The archive is never static, it expands. The most recent Earth is always closest to us. The oldest visible Earth is always farther away. And beyond a certain distance, the planet becomes too dim, too unresolved, too buried in stellar glare to reconstruct in detail. This matters. Because distance creates history, but physics still limits clarity. An ancient telescope could place itself at the right temporal shell. But what it extracts from that shell depends on aperture, wavelength coverage, noise suppression, and integration time. The archive exists. Reading it is another challenge. Still, the idea remains astonishing. Somewhere in the Milky Way, an observer 1,000 light-years away, if equipped with extraordinary sensitivity, would receive a version of Earth where no modern nation exists. No satellites, no digital networks, no industrial atmosphere. Only older chemistry, older agriculture, older weather patterns. A world that, from their perspective, has not yet become technological. Farther away, the historical shells become almost mythic. 100,000 light-years, 1 million, 10 million. The planet's surface details blur, but major atmospheric signatures, reflected light behavior, seasonal albedo changes, and biospheric cycles might still remain inferable. Life announces itself even when civilization disappears. The planet breathes in spectra, and that breath changes with age. This is where the archive becomes deeper than history. It becomes planetary evolution. A telescope does not merely see events. It can, in principle, compare epochs. A younger oxygen balance, a different methane profile, glacial expansion, ocean reflectivity shifts, vegetation signatures waxing and fading across eras. The Earth becomes a sequence, a slow film distributed across cosmic distance. The darkness does not reveal everything at once. It makes you choose a radius, choose a century, choose a phase of becoming. For an ancient intelligence, this may transform astronomy into something more intimate. Not the study of stars alone, but the study of how worlds change before anyone on them understands they are being seen. Perhaps their catalogs would not label Earth by position first. Perhaps they would label it by age state. The pre-industrial blue phase, the carbon ignition interval, the great reptilian biosphere. Not because they misunderstand time, but because time, for distant observers, is inseparable from position. A map coordinate is already a date. This idea quietly dissolves the human instinct to privilege our present. We speak as if history is behind us. But in the cosmological sense, history surrounds us. The Roman sky still exists somewhere. The first flowering forests still exist somewhere. The first oxygenation of the oceans still exists somewhere. These are not metaphors. They are expanding shells of surviving information. The Earth exists as a layered sphere of eras, each one accessible only from a different distance. This is why the thought of an ancient alien telescope feels less like surveillance and more like participation in the same physical truth we already use to study galaxies. They would not be violating time. They would be standing where our earlier light happens to arrive. A perfect patience of geometry. A civilization old enough to persist across stellar lifetimes might build observatories not around stars, but around epochs. Entire telescope arrays positioned at chosen radii from regions of interest, not merely to observe where life is, but to observe when it is. A civilization becomes visible first as chemistry, then as asymmetry, then as a distortion in the night side of a rotating planet. then as radio leakage, then perhaps as spectral scars in the atmosphere. And before all of that, it remains only a world. A young biosphere turning beneath clouds. There is something profoundly gentle in that. The farther away they are, the less threatening the thought becomes. Not watchers, witnesses, not of us, of our becoming. The universe gives every intelligence the chance to encounter another world at a different stage of itself. A civilization may never meet another in synchrony, but it may still meet its history. The darkness between stars becomes a library of delayed civilizations. Shelves measured in light years, volumes measured in epochs. Earth is one such volume, still being written, still being carried outward. And as the telescope gathers photons from a chosen shell, another realization begins to form. Distance can preserve time, but no instrument, however ancient, reads that preserved time perfectly, because every archive is filtered through the physics of the device itself. The mirror, the wavelength, the noise, the patience. What survives into knowledge depends not only on where they stand, but on what their telescope is truly capable of resolving. And that is where the dream of a cosmic archive meets the harder edge of reality. Not every age of Earth can be seen as a clear image. Some eras survive only as faint signatures. A shift in chemistry, a seasonal rhythm, a whisper in reflected light. The next question, then, is no longer whether our past remains visible. It does. The deeper question is how a civilization old enough to think in millions of years would turn those faint layers of light into something recognizable. A planet, a biosphere, a future mind not yet born. The archive exists. But no archive reads itself. Light may preserve the past across distance, yet what any civilization finally understands depends on something far less mystical. The instrument. A mirror. A collecting surface. A geometry designed to pull meaning out of vanishing photons. This is where the dream of an ancient alien telescope returns to physics. Not prophecy, not omniscience, only aperture. The larger the collecting area, the more of Earth's ancient light can be separated from the surrounding brilliance of its star. At extraordinary distances, this becomes everything. A living world is dim, a star is overwhelming. The ratio is brutal. Earth seen beside the sun is like a dust grain near a searchlight. So the first task of such a telescope would not be magnification. It would be suppression. Starshade systems, coronagraphic masking, interferometric nulling. Techniques meant to let the planet survive the glare long enough to become measurable. Gravity still reaches inward. Light still spills outward. But the conversation between signal and noise grows quieter. This is the hard edge of reality. People often imagine a sufficiently advanced telescope as a perfect eye. A device that simply zooms farther until cities, oceans, and creatures appear in cinematic detail. Physics does not permit such generosity. Resolution is not desire. It is wavelength divided by aperture. A strict geometry. At interstellar scales, resolving a planetary disk in visible light requires baselines so immense that even our own engineering imagination begins to strain. Across intergalactic distances, direct surface detail becomes even less plausible. An ancient civilization may solve this with telescope swarms, distributed mirrors spread across astronomical units, perhaps entire orbital constellations acting as phased arrays, perhaps structures built in stable gravitational nodes around their star. But even then, what they reconstruct would emerge from mathematics first, not from eyesight. The darkness does not hand over images. It offers patterns. A slight dip in stellar brightness during transit, a polarized glint from ocean surfaces, a spectral notch where ozone absorbs ultraviolet light, a thermal fluctuation on the night side, a seasonal color drift. These are not pictures in the ordinary sense. They are inferences. The telescope becomes less like an eye and more like an interpreter of probabilities. This is what makes the idea scientifically beautiful. The farther away the world, the less it resembles an image, and the more it resembles a language made of missing photons, of absorbed wavelengths, of repeating asymmetries in light curves. An ancient civilization, old enough to refine this craft across millions of years, may no longer think in terms of seeing planets. They may think in terms of decoding them. Earth would first appear as a periodic disturbance, a rhythm crossing its star, then as a spectrum, then as an atmosphere, then as a chemically unstable biosphere, impossible to explain through simple equilibrium. Only much later would any stronger hint of civilization begin to emerge. The darkness does not yield clarity quickly. It rewards patience. Consider what they could truly know: the size of the planet from transit depth, its orbital distance from repeated timing, its atmospheric composition from starlight filtering through the limb, the presence of water vapor, carbon dioxide, ozone, methane, perhaps even combinations suggestive of persistent disequilibrium, the kind of imbalance that life loves to produce. This is already how our own astronomy approaches exoplanets. The difference is only scale, precision, and age. Their telescope might be older than our species, their algorithms older than our first civilizations, their patience older than our oceans, and still, they would remain bound by photons. There is something almost comforting in that. No intelligence escapes optics. No civilization, however ancient, escapes diffraction. The universe remains fair. It gives information, but never for free. Even if their instrument spans distances we would call impossible, there are still deeper limits. Photon noise, quantum shot fluctuations, interstellar dust, reddening, scattering, background contamination from unresolved stars. At great enough ranges, the Earth's reflected light simply becomes too poor in signal to reconstruct as a resolved sphere. So the instrument must choose. Long integration, different wavelengths, repeated passes, comparative epoch stacking. 1,000 observations merged into one probable world. This is where astronomy becomes memory engineering. The telescope no longer captures a moment. It accumulates confidence. A biosphere may reveal itself not in a single observation, but in the persistence of atmospheric imbalance over centuries of measurements. Cloud structures might emerge not as images, but as rotating albedo harmonics. A continent-ocean contrast might appear only as a repeated brightness modulation. The planet slowly introduces itself, never all at once, never with certainty. This is why the fantasy of a godlike alien eye misses the deeper truth. A true ancient telescope would be more humble and more powerful because of that humility. It would accept that reality arrives fragmented. The work is not to command the universe into visibility. The work is to listen carefully enough that the fragments cohere. The darkness does not arrive all at once. Neither does knowledge. Imagine their observatory network spread across the outer architecture of a long-lived stellar system. Mirror nodes orbiting in silent synchrony, interferometric baselines longer than planetary orbits, cold detectors suspended in permanent shadow. All of it focused on a dim blue point whose photons left millions of years ago. Yet even with such impossible engineering, they still would not see Earth as we imagine it. No clouds rolling across continents in real time, No city skylines glowing in obvious grids, no creatures moving beneath forests. Instead, they would recover signatures, a rotating asymmetry every 24 hours, a spectral edge hinting at vegetation, a thermal contrast between day and night. Perhaps much later, a strange excess on the night hemisphere inconsistent with pure geophysics, a whisper of artificial illumination. But even that would remain interpretation. The instrument never grants absolute certainty, only narrowing ranges of explanation. This is what turns the telescope into a philosophy of evidence. The older the civilization, the more deeply it may trust indirect truth. Not because it enjoys uncertainty, but because the cosmos itself is indirect. The light arriving from Earth has crossed dust lanes, magnetic turbulence, molecular clouds, gravitational lensing distortions, and the slow red-shifting stretch of expanding space. By the time it enters their mirrors, it is not a scene. It is a survivor, a fragment that endured the journey. And the instrument's task is to decide what kind of world could have produced such survivors consistently. This is why the telescope matters more than distance alone. Distance preserves the archive. The telescope decides whether the archive can be read. A small mirror sees noise. A larger mirror sees atmosphere. A distributed array sees rotation. A civilization-scale observatory begins to infer climate cycles. A million-year observing program might detect industrial chemistry emerging in a planet's delayed future shell. The instrument transforms chronology into knowledge, but always through limits, always through physics. This is the elegance of the idea. An ancient alien telescope is not terrifying because it sees too much. It is profound because even it must work for every truth. Every answer about Earth would arrive through signal extraction, noise rejection, probability weighting, spectral reconstruction, Bayesian patience written into hardware. A civilization old enough to endure cosmic timescales may understand something we are only beginning to learn: that seeing is overrated. Inference is deeper. A world becomes most real, not when it is photographed, but when multiple lines of weak evidence converge into one unavoidable explanation. Oceans, weather, oxygen, seasonal growth cycles, a rotating biosphere. Perhaps eventually a technological metabolism, not a city, not a face, a metabolism. This is the point where the archive of time meets the instrument of reason. The past is still there. The photons still arrive. But what survives into understanding depends entirely on the telescope's ability to transform impossibly faint structure into meaning. And once that threshold is crossed, the next step becomes even stranger. The question is no longer whether Earth is alive. It is whether the patterns inside that life suggest intention. Industry, artificial energy gradients, night-side excess light, chemical traces no forest would invent. The telescope has taken them as far as biosphere. The next movement of the film carries them toward mind. A living planet does not hide quietly. Even before intelligence, it begins to lean against equilibrium. Its atmosphere drifts into combinations that chemistry alone struggles to sustain. Its oceans regulate heat. Its clouds repeat patterns. Its seasons leave signatures in reflected light. Long before a civilization announces itself, life changes the way a world glows. This is where the ancient telescope crosses an invisible threshold, no longer asking only, what kind of planet this is? Now asking something stranger. What kind of processes must be active for light to look like this? The difference is subtle, but profound. A dead world can still be beautiful. A volcanic world can still shimmer with spectral complexity. A frozen moon can still flash with geometric brightness. But a living world develops habits. Repeated atmospheric disequilibrium, persistent oxygen where it should vanish, methane replenished too quickly, seasonal pigment shifts, a hydrological rhythm too stable to be random. These are not declarations of life. They are invitations to infer metabolism. The darkness does not give answers. It offers stubborn inconsistencies. To an ancient civilization, perhaps one that has spent millions of years cataloging planetary spectra, these inconsistencies would feel familiar. Not because they have seen Earth, but because they have learned what chemistry looks like when a planet begins to resist stillness. A biosphere is a kind of restlessness. The light from Earth, filtered through oceans, clouds, atmosphere, and surface chemistry, would gradually reveal that restlessness. Ozone absorption, water vapor, carbon dioxide cycling, a reflective spectrum whose balance shifts with continents rotating beneath weather systems. Perhaps even a faint vegetation edge, not a forest, not trees, only the spectral fingerprint of pigments harvesting starlight. A whisper that the surface is busy, a whisper that the planet is doing something. This is where science remains grounded. Even our own telescopes are moving toward this frontier, not to photograph alien forests, but to detect the atmospheric and photometric consequences of processes that may only make sense if biology is present. An ancient telescope simply extends that logic with more patience, more sensitivity, and far longer baselines of evidence. The darkness does not arrive all at once. It learns in layers. At first, Earth is only a stable rocky planet in the habitable zone. Then a wet one. Then a chemically active one. Then something stranger. A world whose atmosphere appears to be maintained far from thermodynamic simplicity. The kind of persistent imbalance that suggests cycles. Feedback, repair, consumption, renewal. A living system is not a thing, it is a rhythm. And rhythms survive distance better than images. A civilization old enough to master this kind of observation may not think in terms of life as a binary state, alive or dead. Instead, they may think in gradients of planetary complexity, geochemical, biochemical, ecological, technological. Earth, viewed across different temporal shells, may climb those gradients slowly. An oxygen-rich phase, a complex seasonal phase, a civilization phase. And perhaps this is where the telescope begins to sense something more than biology. Not certainty, pattern drift, a deviation from the expectations of planetary metabolism. The night side of the planet becomes slightly brighter than pure thermal redistribution predicts. Not dramatically, only enough to raise a probability flag, an energy gradient where darkness should be cleaner. A repeating geometric modulation inconsistent with cloud systems. A spectral line corresponding to molecules difficult to explain through volcanism or ocean chemistry alone. Nitrogen compounds in odd ratios. Industrial fluorinated residues. Persistent atmospheric scars. No single anomaly would prove intelligence. That is the rule that protects science from mythology. But anomalies can converge. A world first recognized as alive may later become recognizable as organized. This is the threshold between biosignature and technosignature. The planet no longer merely metabolizes, it reshapes, it engineers. It alters its atmospheric story faster than geology prefers. For an ancient civilization, the most convincing sign of mind may not be city lights. It may be accelerated disequilibrium. A world whose chemistry changes on timescales too short for tectonics. A world whose night hemisphere emits faint but stable excess energy. a world whose radio leakage once emerged and then quieted as technology evolved beyond wasteful broadcast. Mind does not need to be seen, only inferred from consequences. This is what makes the thoughts so haunting. They may never know our faces, never hear our languages, never understand our symbols, and yet the planet itself may begin to betray the existence of abstraction, tools, industry, deliberate control over matter. The atmosphere becomes an autobiography written in trace gases. The night side becomes a diary of energy use. The orbital environment, if resolvable, might begin to hint at artificial structures, not giant megastructures in the science fiction sense. More subtle, repeated reflective anomalies, transit edges too sharp, non-natural phase behavior, a cloud of orbital debris whose scattering signature slowly evolves. The darkness does not reveal minds directly. It reveals the worlds minds leave behind. There is something deeply elegant in that. A civilization can remain invisible in every personal sense. No image, no body, no voice, and still become undeniable as a planetary process. Earth itself becomes the message. A world that once merely breathed now begins to compute, to manufacture, to leave scars in spectra and faint order in the dark side glow. For an ancient observer, this may be the moment where astronomy turns almost philosophical. The telescope no longer studies a planet alone. It studies the possibility that matter on that planet has begun to model reality, to build instruments, to wonder, to alter the light that escapes its world. Perhaps this is why the idea feels less frightening than intimate. They do not discover us. They discover that Earth has crossed a threshold where blind chemistry no longer explains the whole pattern. The world has become reflexive, a planet whose atmosphere now includes artifacts of intention, a biosphere that has learned to modify itself knowingly. And because they are distant, what they see may still belong to our earlier centuries. Coal signatures strengthening, industrial aerosols rising, the first hints of chlorofluorinated chemistry, radio leakage blooming and then fading. From their perspective, they may be watching intelligence emerge, not arrive fully formed, a mind in planetary slow motion. The archive of distance transforms civilization into a developmental sequence, not a single species, a gradient from life to intention. This is the gentlest way the universe allows one intelligence to encounter another, not face to face, but through the environmental consequences of thought. The planet glows differently because minds have begun to act within it, and yet even this remains incomplete. The deeper mystery is not whether Earth hosts intelligence. It is whether intelligence, once it appears, remains stable enough to be visible across multiple delayed shells of time. A civilization may flare, then vanish. Its chemical fingerprints diluted by centuries, its night-side glow gone dark, its orbital geometry cleaned by decay. Mind may be detectable only as a brief disturbance in the archive, a thin, bright layer between deeper biological ages. This gives the ancient telescope one final and unsettling power. It may not merely detect civilization. It may estimate how long civilizations survive, how quickly they rise, how rapidly they alter planetary chemistry, how suddenly they disappear. And somewhere inside those stacked shells of Earth's delayed history, one of those layers may correspond to the first unmistakable moment when our planet ceased to be merely alive and became thoughtful. Beyond that layer, farther into older and colder radii, the signals fade back into forests, oceans, and atmospheric breathing. The mind has not yet happened. Which means the final question is no longer whether they can sense intelligence. It is whether, from a still greater distance, They might be watching a version of Earth where humanity has not yet been born at all. Far enough away, we disappear. Not because we are gone, but because, from that distance, we have not happened yet. This is the final quiet truth hidden inside the idea of an ancient alien telescope. The farther the observer, the younger the Earth. The younger the Earth, the less of us remains in the light. At some immense radius, all signatures of industry dissolve. The night side darkens. The atmospheric scars soften. The radio leakage has not yet begun. The orbital debris has not yet formed. The planet returns to weather, to oceans, to cloud bands wandering over continents untouched by design. The telescope is still watching Earth, but it is watching a silence older than humanity. This is where the archive of distance becomes something more than astronomy. It becomes humility. We spend so much of our lives imagining the present as the center of reality, as if our century is somehow the definitive version of this world. But the universe refuses such privilege. It distributes Earth across eras. At one distance, mines have risen. At another, only forests. At another, no forests yet at all. A molten world beneath a dimmer sun. A sky rich with chemistry, but empty of memory. The darkness does not preserve identity. It preserves sequence. And sequence is enough. For an ancient civilization, this may be the most profound revelation of all. A planet is never one thing. It is a history stretched through space, a living chronology, a stack of delayed truths. Somewhere their telescope may be studying Earth in its carboniferous abundance. Great forests breathing oxygen into the air. Insects larger than modern birds moving through humid green twilight. Elsewhere, from a still greater shell, the same world is only ocean and storm. Earlier still, a haze-veiled sphere where life has not yet climbed onto land. And beyond that, perhaps only the chemical uncertainty of young seas. The Earth exists as many beginnings, not because reality splits, because light separates. There is something strangely beautiful in knowing that humanity is only a thin, luminous layer inside a much deeper planetary archive. A brief techno-signature shell. A narrow radius where thought becomes detectable. Before it lies biology. Before biology, chemistry. Before chemistry, accretion. Each stage still moving outward, each stage still available to a distant witness. The telescope, patient beyond civilizations, does not see us as permanent. It sees us as transition. A phase, a thermodynamic episode inside a much older planetary story. This is why the idea becomes existential without becoming anxious. We are not erased by distance. We are contextualized by it. The farther the gaze, the more Earth returns to what it was before us. A world not waiting for humanity. A world entirely complete without thought. Clouds crossing oceans, auroras over empty continents, moonlight touching beaches no mind has ever named. The ancient telescope would not experience this as absence. Only chronology. A younger shell. A quieter chapter. And perhaps, somewhere unimaginably far away, the Earth they study is so young that even multicellular life has not yet emerged. The oceans are rich with possibility. The atmosphere unstable, searching. A biosphere still learning how to persist. From their perspective, the future intelligence we call humanity exists only as potential hidden inside chemistry. Nothing in the photons announces us yet. No oxygen-rich abundance at modern levels. No chlorophyll edge. No city glow. No machine signatures. Only a world rehearsing the long mathematics that will one day allow a nervous system to ask questions. This may be the gentlest answer to the fear hidden inside the original thought. What if something ancient is watching? Perhaps they are. But what they see may not be us. They may be watching Earth before names, before memory, before the first vertebrate eye ever opened beneath shallow seas. The telescope becomes less an instrument of surveillance and more an instrument of perspective. It reveals that identity itself is local. To us, humanity feels central. To a distant observer, it may not yet exist. To another, it may already be fading into a past shell. Civilization becomes a narrow band in the spectrum of Earth's existence, a bright, transient interval between deeper biological ages. The darkness does not arrive all at once. It removes us gently. First the city lights, then the industrial chemistry, then the agricultural reshaping of landscapes, then even the forests we inherited from older climates, until only oceans remain, then clouds, then basalt, then fire. This is what the ancient telescope ultimately teaches. Not that we are being watched, but that every civilization occupies only a thin radius in the expanding memory of its world. A shell, a delayed brightness, a temporary readability. The Earth was ancient before thought. It will remain ancient in every delayed shell where thought has not yet formed. And this transforms the entire meaning of cosmic loneliness. We are not simply asking whether someone might see us. We are asking whether any intelligence, anywhere, ever truly sees another civilization in the same moment. Perhaps synchrony is rare. Perhaps the universe mostly offers us one another's younger worlds. One civilization sees oceans, another sees forests, another sees chemistry, and only by extraordinary coincidence does one witness another at the exact layer where minds are bright enough to alter the planet measurably. This is why the final image is not frightening. It is tender. Somewhere in the dark, older eyes may rest upon a younger Earth, a blue sphere turning beneath storms. No cities, no languages, no music, no telescopes pointed back, only weather and possibility. A world not yet aware of the stars. And perhaps that distant civilization, patient enough to think in stellar ages, understands something we are only beginning to feel. That every intelligent world is first a silent world. Every civilization is preceded by oceans, by chemistry, by long eras of blind becoming. Mind is not the whole story, only a late chapter, a bright and delicate layer inside a much older planetary memory. The farther they stand, the more clearly this becomes visible. Earth before us, Earth without us, Earth as potential, Earth as the patient preface to consciousness. And maybe that is the most beautiful thing their telescope could ever reveal. Not proof that we are observed, but proof that every world carries within it many versions of itself, spread outward through space like pages torn gently from time. Some pages hold cities, some hold forests, some hold nothing but rain on stone. And in one distant shell, perhaps the one they are reading tonight, Earth is still waiting for the first creature to look upward and wonder whether anyone else has ever seen this sky before. This has been another entry in Diary of the Cosmos. Until our next journey, remain with the stars.